Alright, so hello everyone. In this video, I'm going to share with you um, how to use SPSS version 30, but it's not that important because generally the interface would look the same. And again, well, this tutorial is for beginners, um, for people who don't know much about statistics, and it's not meant for intermediate, or advanced user of SPSS already. Alright, so let's first walk through the outlines of today's tutorial. We'll first talk about some basic statistical concepts or terms, and then we will talk about selecting appropriate statistical analysis, how to select appropriate statistical analysis. And then we'll have a practice session where I will demonstrate how you can use SPSS to perform basic functions for data analysis, quantitative data analysis, import data file, run common descriptive and inferential statistics, and interpret the results. All right. So for the key terms, we need to know a few common terms in statistical analysis. The first one is variable. So variable represents the columns in your data sets. It captures characteristics of attributes of your measure, or in general, variable, they're just very general terms to indicate the constructs or what are you trying to measure in your data set, like age, test scores, and gender. Now, another concept is independent variable. So independent variable is the variable that influences or predict another variable. It's more common when you do prediction analysis. Okay. So independent variables usually indicate group. For example, if you are implementing a teaching method, it can be the control group and then the experimental group, or you can call it traditional or gamified group, right? And then we have dependent variable, which is the outcomes you measure, such as language test scores or the fluency levels. So that's called independent. Usually we'll use that's called dependent. So usually we'll use independent variable, which is IV, to predict dependent variable, DV. Alright. Now another concept called variance, which indicates the spread, how spread the data points in your data sets are around the mean, and it indicates the variability or dispersion in the data sets. And for example, you have two groups of participants with test scores, and what you want is that the variance is similar for two groups. Yeah, because if the data points spread in a different way for two groups, then certain statistical assumptions are not met, and you may have to you can still run the statistical analysis, but you may have to adopt a different one. All right. Now for data type, we have three common types in SPSS. The first one is nominal, which basically means just categories without order. Like you have male and female, we don't have an order, like male first or female, doesn't matter. And then we have the ordinal data type, which is category with an order, and usually this is the result when you use the Likert scale, or you can say it's proficiency levels. As example, we got beginner, intermediate, and advanced. So these is this in order. Okay. The third types of data are called continuous numerical values, or it's called scaled, which indicate test score and age and things like that. Alright, so now I have just briefly discuss variable, independent variable, dependent variable, variance, and data type. Now we come to the two major types of statistical analysis. The first one is descriptive statistical analysis. Okay, so descriptive usually tell you about the frequencies, the means, the standard deviation, or used to summarize and describe data trends. So frequency, like how often, how many percent. It means like what is the average score. Standard deviation, like the spread around the mean. This gives you very basic and general info into the data. And then we have inferential statistics, which is more advanced, and it basically involve a wide range of tests, but the common one is the t-test. And then we have the correlations, the regressions, or prediction. Okay, it helps you to draw conclusions about relationship. You want to explore whether there is a relationship or difference. Okay, whether there are differences between two groups, or whether there are different, or relationship between two variables, or 3 or 4 variables or more. Right. The last concept is p-value. So p-values indicate the probability of your results occurred by chance. Usually a p-value p-value often it has the p here, and usually a p-value is less than 0.05 would indicate statistical significance. So statistical significance, it gives you the confidence to say that something is effective, or something, there is a significant correlation between two variables, and that is because of something, because of a factor, and it's not by chance. Okay, so usually you want to see the statistical significance in if you are implementing an intervention or an experiment, for example. All right, now we come to the second part, which is selecting appropriate statistical analysis for your study. Now, these are some tips for you to consider, but you need to identify what is the dependent, what is the independent variable. Now, this is particularly relevant if you are trying to conduct a regression or prediction analysis, where you want to use either a predictor or independent variable to predict the outcome. All right, for example, you want to see if motivation can predict language achievement, so you use motivations as a predictor, or in this case you are implementing teaching method, and you want to see if a certain method, whether it's a gamified or traditional flashcard, can predict the test score. In this case, the test score or the outcomes can be considered a dependent variable. All right. It's also important to know if your data is nominal or ordinal or scale, because these might determine what kind of analysis. Okay, but in general, it's quite flexible at this point. And for beginners, I probably won't get too much into what the difference in terms of the statistical analysis for different types of data, because it won't affect much. Alright, something else that I like to emphasize is that your statistical analysis should be informed by your research question or by the theoretical framework. Alright, so when you design a survey, you must have a reason for it, like how many sections, how many dimensions of the survey, of the scale that you are using. Okay, so it should always have a theory or a framework behind. Now I'd like to show you an example. For example, I'm open the PDF, and the PDF is of a scale called the motivated strategies for learning questionnaire, or in short they call it MSLQ. Okay, and this is a scale to measure the motivated strategies, but it have a different dimension. Quite a few dimensions. Now if you look into this, so it's got the motivation scales, which had three sub dimensions: value dimension, expectancy, and affective components. Okay, and then the learning strategy, they also have different dimensions. So you see that this is a survey with 81 questions, and it is divided into different dimensions, and these dimensions must have a theories or a theoretical underpinning behind it. So the same thing for us when we design a questionnaire or a survey or a scale, we need to have a theories or a framework. So when you do the statistical analysis, you look at the theory or what are the dimensions of the scale, and then you can run analysis based on the theoretical insights. Okay, we don't just run analysis because we think, this should, be that this way and that way. We need to draw on theories or previous research. Alright, that's pretty much. And part 3 for today's tutorial is SPSS practice session, right, where you need to import a data file, declare variables and categories, and then we can just run the stat. Alright, I'll demonstrate how to do that. First, you open SPSS. Okay, you need to open it first. Alright, so this is SPSS version 30, and I'm using the trial version of it. Okay, so you open that one. You select new data set. If you already have other, you can click open as somehow, but for me to demonstrate, I will select new data set and I click open. Alright, now this is an empty data set with nothing in here. So you want to import the data, you go to file and import. Now you have different options. You got Excel file, CSV, SIS data, and other, but most often we use Excel or CSV. So I click on Excel. Okay. Now if I go to my desktop, where's my desktop? Let me see if I can see my desktop. Okay, now if I go to my desktop and then I go to the folder where I have the sample data, I click on that one, and it will show me, it will ask whether I think this is the right data set. Okay, the right data set. Alright, so if it looks proper, and then there's some option here, you may want to read it, but for now it looks so good for me, and then I'll just click on OK. Alright, so you wait and it will pop up a data view. Okay, there's a window called data view. Now it looks all in. We got a gender, the age question. Here I have 50 questions. This is the question from the motivated strategies for learnings, right? Yeah, for learning questionnaire. Okay. Now I want to show you what questions in the data. Now you see that this original data set have 81 questions, but in this tutorial we don't need 81 questions. We only need a few questions like this. Okay, so For example, question 1, in a class like this, I prefer course material that really challenges me so I can learn new things. Alright, so that is the full text of the question, but I don't need the full text. I just, when we do analysis, we want to have a very simple heading, so it is easier for us to manipulate the variables later. So I just write Q1, Q2, Q3, alright. But if I want to check what the Q3 is, I go back to this file to see. Now, alright, now you go to the variable view. You see that in the variable view, we need to declare, you see, we need to declare the variable type and the category. So the type, so this is nominal because it is gender, and it's not ordinal because there's no order. It's not scale because it's not number. So for gender, we select nominal. Okay, and then for age, we look back at the data view. You can toggle between two views. Now for age, it's a number, so I will select scale. Okay, for Q1, Q2, Q3, it is like a scale. Okay, it is actually like a scale from 1 to 7. Okay, so that's not nominal. We select ordinal. Okay, and then you can do for the rest. But to save time, I think we can just copy. Yeah, we can just copy, and then we select all of the other, and then we paste it in. Okay. See, okay, it's applied now. All are nominal. So that is for the type. Now we need to define value too. Okay, so we need to add value. So one is male. So the value male is male, and the value female is female. Female. Okay, so let's just save this. Just click OK. Definition. No. Okay, now we can just say label male and female. That means female. Okay, sometimes if your data has here 1 for male like this, if your data is like if instead of male female you write 1 for male, 1 for male, 1 for male, something like that, then you need to declare differently. You need to declare this one as 1. Oh no, sorry. You need to declare, instead of male, you need to write 1. Okay, so it match with your data. Okay, but in this case my data I write male, so I can just leave it as male. Okay. Okay, I need to go back and then fix this one. Male. Alright, so that's pretty much for the data view and declaring variable. Okay, for the other it's just number, ordinal, so I don't need to declare value for them. Just the gender. We got 2 groups. Now what next? Okay, what's next? Now if you want to do some sort of descriptive statistics, you go to here and you go to descriptive. You got frequency here too, so it's up to you. Okay, to demonstrate I just say descriptive, and then a window pops up. You can just select a field, for example age. For example, I want to see the first 10 questions. Type it in. Okay, and then you can click on option 2 to see if you want to see the variance. Or range. Okay, It's up to us. And then we click on OK. And this will show you the outcome, and which is the number of participants who fill out the survey, the range, mean and max, and then what is the mean? The mean age is 20, and then standard deviation, which is the spread, and then the variance of the variable. Okay, mostly you have to decide which is the column that you want to report in your research. Often it is mean and standard deviation. For the other, it's mostly optional. All right. So that is for descriptive statistics. Let's try the frequency one. Okay. How about frequency? So we go back to analyze descriptive frequency, and we click gender and age. For example, click on statistics. You can add mean. Okay. You can add standard deviation as well. Continue. You can even draw a chart. You can have bar chart if you want, or yeah, you can have bar chart. You can show percentage or frequency, format. Okay, so these are optional mostly. For the style, optional too. I think that pretty much that's it. Oh, this you have the IPA style typo too. So if you want, you can click on that one and click OK. And we wait, and we see it generates IPA style typo. You see some descriptive statistics. Excuse me. So it shows you gender, age, what is the mean for age. For gender, we don't have the mean. For gender, we have 50 female and 8 male, and the percent. All right, and it even draw chart for us, so which is quite convenient. So that's pretty much for the descriptive statistics. You can choose frequency or descriptive. We do have other options, but because of the time constraint, I probably won't go through all of them. But these are the most common requirement for research report. Now, the next one is inferential statistics. We're going to start to run t-tests. T-tests basically compare the means between two groups. For example, you got control versus experimental. Okay. So the way you do t-test is that you go to analyze, compare means and proportion and independent t-sample t-test. If you are running pre-test post-test for the same group, you go to pairs sample t-test. But if you want to do different groups, okay, like experimental and control, you go independent sample t-test. All right, you click on that one. In this case, we don't have the experimental and control. We only have gender. So I click on gender. I go to group and variable, and then for example, I click on question 1, 2, 3. For first 3 questions as the test variable. Okay, for this one, when you click on gender, because there are 2 groups, you need to define group. All right, group 1 you define it as male, group 2 you define it as female, because in our data we write male and female. Group 1 is male, group 2 is female, so we're gonna write something for that. Okay, and you click okay, have a look at it, option. All right, so these are, we can use the default for this one. Click on OK, and it will show you the group statistics and then independent sample t-test. Okay, so because we select 3 questions to do independent sample t-test, So we're gonna look at them. Now, there is the first column called Levine test for equality of variances. Usually we want it to be more than, we want it to be non-significant, okay? And we read the first line if it is non-significant. When I say non-significant, it means p more than 0.05, okay? And this is non-significant. Okay, we'll look at this. So if it is non-significant, it means equal variance is assumed, and we read on this line. So yes, it is non-significant, okay, for the Levine test. But for the t-test, we often want it to be significant. Significant means there is a difference between two groups, and this difference is a statistical difference. It does not happen by chance, okay? But in this case, we see that the p is 0.9, yeah, which basically means there's no difference, okay? The same can be used to interpret other. This one is 0.05, but it's not less than, so we can still consider it as so this is a bit tricky because it's marginally significant, okay? So it depends on the research, but in this case, if you want, you can interpret it as non-significant, and then if it's non-significant, you interpret the first line, okay? All right, for question 3, it is also the Levine test, also non-significant, and we read the first line. We read the two-side p-value, and the p here is all more than 0.05, which is non-significant. So what the results are telling us is that there's no difference between male and female in answering question 1, 2, and 3. All right. But this is just an example, question 1, 2, and 3. In your research, instead of passing in question 1, 2, and 3, you may have your own variable like linguistics achievements or motivation or efficacy, whatever. All right. Instead of passing question 1, 2, 3, you can pass in your own variable in your research. What I just did is just to demonstrate, okay, how to do it. Compare t-test. Again, go to analyze, compare means, and go to independent sample t-test. If you, we don't have time to demonstrate, but if you measure the same group, pre-test and post-test, you use pair sample t-test. All right. Okay. Now the next analysis I'd like to demonstrate is correlation. So we want to investigate if there is a relationship between variables. It can be 2 or more. So for example, how you do it is you go to analyze and you go to correlate and you click bivariate, okay, and then you select the variable you want to see. Now for example, I want to see if there is a relationship between age and question number 1, okay. Now if you want to know what question number 1 is, you can go back to the questionnaire. In class like this, I prefer course material that challenges me so I can learn new things. Alright, so I want to see if there is a difference in responding to question 1. If people have different age, okay, often we use Pearson correlation. There are other, but Pearson is the most often used. Alright, you click on option to see if you want to report means and standard deviation. You can click on this, click continue, and you click OK. Alright, now here you got mean and standard deviation as you tick on the boxes. For the correlation, you see we got the Pearson correlation. Often these are 2 are the same, H and Q1. The neckline is Q1 and H, basically they are the same. What we want to look at is first the correlation. It is negative, and then the significant value is more than 0.5, which basically means that there is no statistical significance, which means the age is not, there is no difference in answering question 1 among participants older or younger. In other words, the age has no effect. The negative here mean the reverse relationship. Reverse relationship or negative relationship, it means that one variable increase and the other will decrease. In this case, because this is a motivation questionnaire, we can say that if the age increases, the motivation decreases. So that's why it's called negative relationship. Okay, the last test that I like to demonstrate called regression, or simple linear regression, or we can say it is a prediction analysis. So we're using an independent variable to predict a dependent variable. So to run that, you go to analyze well, you go to regression, and you go to linear. Okay, you go linear. Okay, now what you want to do is you put in the dependent. Now, for example, I want to use gender. Okay, so string not allowed here. So we use age to predict what? To predict the outcome of question 1. Now, all of the question here is a motivation question. So, so this is an example. So we can just select any. But in reality, when you do your research, you may have to do like some calculation, a sum of question 1 to 5, for example. But this is just a tutorial, so I can just pick any question. I put in question 1 as a dependent, and then age as independent. I want to use age. I want to see if age can predict the motivation. So again, you can click on statistics to see if you want to have a more detailed result. If you want to plot, usually this one, we can use that. Let me see which one. Yeah, we should skip this for now. Okay, option. All right, so these don't look good. We can just skip it like that, and you click on OK. Now you see that it will show you what in the result. It will show you the model. In the model, you want to see if there is significant. You look for the p-value, significant change, and this is the p-value here, and there's no difference, or no, it's not significant because the p is 0.912, which is more than 0.05. So what that means is that age is not a significant predictor. In other words, age does not have an effect, and you can't really predict the motivation using age. You know, people with different age can have different types of motivation, and we don't know what the reason is, so we can't use it to predict. Okay, so this is the ANOVA as well. So if you look at the coefficient table too, see that the age is not a significant predictor because the sig or the p-value here is more than 0.05. Okay. Now in other scenarios, you may see that the p-value here is smaller than 0.05, and it will be considered significant. For example, if age is still the predictor, but then this one is smaller than 0.05, so we can say that age is a predictor. But in this case, no, age is not a predictor because the p-value here is not statistically significant. All right. So that's it. So I have just demonstrated how you can use SPSS to import a data file, to declare variable types and categories, to run descriptive statistics and inferential statistical analysis. And I'll show you how to interpret some results as well. Okay. Again, so these are very basics, and this tutorial is for beginner. If you want to use it for your research, you do need to consult your supervisor or experts, or someone who knows uh, statistical analysis better than you to make sure that everything is correct. And before I conclude the presentation, I'd like to remind everyone again that it's very important that your survey is designed based on a theoretical framework, and whatever your analysis you are running, it needs to be informed by the framework as well and be driven by your research question. We don't do random analysis. We need to have a reasons or justification for that. And that's pretty much for today tutorial with SPSS. Thanks a lot for watching, and bye for now.